Okay, so variance and standard deviation. So the standard deviation of your data, as it says, is a measure of how spread out it is from the mean. Okay, so if your standard deviation value is high, it means that your data is quite spread out, compared to the mean. If your standard deviation is small, it means that your data is all quite close together. Now, when I say big versus small, obviously that's always in comparison to the data values you're looking at. So for example, if we were looking at number of siblings, don't go on about the step half business, then if we had a standard deviation of 4, that would be a big number in comparison to what my mean or my data in general is. So that makes sense? Yes? Because a difference, like a standard deviation means it's spread out quite a lot. If I was talking about people's salaries, okay, so we're talking thousands of dollars, if I had a standard deviation of 4 there, that would obviously be a very small amount. Does that make sense? Yeah. So when I say big and small, it's always in comparison to the actual data values you're looking at. That's the most important thing, yes? Because some people say, yeah, but you said it was a big number or a small number. Well, yeah, but look at what we're actually looking at, yes? There's lots of words here. Basically, I copied it from a book, and you don't necessarily need to absorb all of the words. So as you can see here, so this red bump here, that's got a low standard deviation because all your data is very close together. It's not very spread out from the mean. This would be a high standard deviation because it's a lot further spread out. Yeah. It's only used to measure spread or dispersion. Check. It's never negative. Okay. So what you would say is you would have your mean value and you would say it's 1 standard deviation away from it or 1 standard deviation below it. So you could talk about how many standard deviations there are, but you would never say it's a negative standard deviation. For data of approximately, say mean, the greater the spread, the greater the standard deviation. If all values in the data set are the same, the standard deviation is 0. Okay. Now these are fancy pants formulae for it. This is going back to the sigma notation. Do you remember that? Yeah. So it's the sum of stuff. So this is our frequency multiplied by our data value. Subtract the mean, all squared, and then you add them up and divide by how many data values there are. Now. I have not ever seen you have to calculate the standard deviation on a paper 1 question, so you should always have your calculator available to you. They give you these formulae. Not quite sure why. Let's watch. There'll be some kind of random question that you need it, but I've never seen one up to this date. Most 99% of the statistics questions will be on paper 2, where you'll have your calculator available to you. Okay. Now. I've been talking about standard deviation a lot and not a lot about variance. Well, the only difference between these 2 formulae, can you see a difference? There's no square root, and then this says Sn, and this says Sn squared. So that's all the variance is. It's this value squared. Okay? Right, so 30 farmers were asked to, how many blah, 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 calculate the mean and standard deviation. So we're going to input this data into our calcs. And then I'm going to show you which is the symbol that shows you standard deviation. All right, so it's this one here that you're wanting. Oh, I've lost it. This is the sample one above it. This is the population standard deviation. And the mean, how do we know it's the mean? Do you remember? Which X with a bar on the top. Yeah. Okay.
Excuse me, I'm done.
All right, so these questions essentially it's just practicing shoving them into your calculator. So what did we find the mean was? 5, and what was our standard deviation? 2.25. So I would suggest that that's quite a high number. Yes? If your mean is 5, you're saying that 2.25 is in comparison to that. That's how far your data spread away from that. I'd say that's quite a big number, no? Okay, what it's saying is that here's your mean, and your data is spread out 2 units from that.
Oh, God, that is so like 3 and 7.
Now, yeah, but but within your data, essentially, you normally have 3 standard deviations this way, 3 standard deviations that way, will give you all of your data values. Okay, so I would say that 2 is quite a big number in comparison. Like if we were talking about 0.47, that's tiny baby. That means everything's close together. But I would say 2 compared to a mean of 5 is quite a big number. Does that or not?
Yeah,
Do you understand that or not really?
No, I know what you're saying. Yeah, because 3, 1 can still work.
Yeah?
Yeah.
Okay. But this thing here about the 3 standard deviations from either end. So that should encompass all of your data 3 standard deviations away. There's lots of percentages about how many are 1 standard deviation away, 2 and 3. But you don't need to learn that, I'm pretty sure, for your course. So don't worry too much about that. But yeah, okay. I forgot about this. Now, this here, these questions are coming up more and more and more. So it says here, the effect of constant changes to the original data. So what they might say is that your data had a standard deviation of blah, blah. What would happen if? So it says if you add or subtract a constant value to or from your number, every number in your list, then the mean is going to increase or decrease by that value. Makes sense, yes?
Yeah.
So every single data has had something added to it or subtracted from it, which means your mean is going to increase or decrease by that value, right? But your standard deviation is not going to change at all, because the spread from your mean is not going to have been affected. Does that make sense? Because you've added it to everything. So essentially what's happened is that your data was sat here. Here's your mean, here's your standard deviation. Now the whole thing's shifted, but the spread hasn't changed because you've shifted them all up. Does that make sense?
Yeah.
If you multiply or divide all the numbers in the list by something, then the mean and the standard deviation are going to be multiplied by that value. Okay? Yes?
Mm-hmm.
Now, obviously that's the mean and standard deviation. The variance is then affected by the standard deviation. Okay? So the variance would be your standard deviation multiplied by that number squared. Okay? So just have a look at this and try and absorb it, because as I say, they're becoming more and more popular questions to actually ask. Right, yeah. Okay, I think that's it. The variance is the standard deviation value squared.
If you go through the second way again.
So if you multiply every value in the thing, then your mean is going to be changed, obviously, but your standard deviation would also be changed, because what's happening is that everything is being multiplied by something, so you're making it the spread bigger as well. I'm doing that as though that's giving you everything you need to know. But if you add, you're just shifting it along the thing. Whereas if you're multiplying it, you're doing that.
Yeah.
Yes or no?
We got this.
Yeah? Okay, so yeah, I would say just kind of absorb this bad boy, and it should help. Okay?